Welcome to the virtual tutor series on core mathematics for senior high schools. This is part 2 of the lessons on expansion of algebraic expression. In this lesson, we take a closer look at the expansion of perfect squares and difference of two squares. All the previous lessons on algebraic expressions can be accessed on the TVTL's YouTube channel. As always, please take your book and pen as you follow along. We begin with expansion type 3, which is perfect square. A perfect square is a number that can be expressed as the square of an integer. For example, 4 is a perfect square. In other words, 4 can be expressed as 2 times 2, which is equal to 2 squared. In much the same way, a plus b all square and a minus b all square are perfect squares. An expression of this nature can be expanded by 1. Squaring the first term, 2. Multiplying 2 by the product of the first and the second terms, and 3. Squaring the second term. With these steps, let's see how we can expand the above expressions. So we have the first expression to be a plus b all square. In this expression, a is the first term and b is the second term. The first step is to square the first term. So we have a square. The second step is to find the product of the first and second terms and multiply the result by 2. The product of a and b is ab, and 2 times ab is 2ab. And the third step is to square the second term. So we have b squared. The next expression is a minus b all square. We have the square of the first term to be a squared. The product of a and negative b is negative ab, and 2 times negative ab is negative 2ab. And the square of the second term is b squared. Note that negative times negative is positive. Thus, negative b times negative b is b squared. Let's consider the following examples. Expand the following expressions. Solution. Example 1. 4a plus 5b all square. Step 1 is to square the first term. So we have 4a all square. Step 2 is to multiply 2 by the product of the first and second terms. So we have 2 into bracket 4a times 5b bracket close And step 3 is to square the second term. That is 5b all square. For a all square is 16a square. 4a times 5b is 20ab, and 2 times 20ab is 40ab. Finally, 5b all square is 25b square. Example 2. Into bracket 2x minus 5y, bracket close, all square. The square of the first term is 2x all square. 2 times the product of the first and second terms is 2 into bracket 2x times 5y, bracket close. And the square of the second term is 5y all square. 2x all square is 4x square. 2x times 5y is 10xy. And 2 times 10xy is 20xy. Finally, 5y all square is 25y square. Good job! Now, let's proceed to expansion type 4. Difference of two squares. In our previous lesson, we learned that the product of two binomials can be expanded by multiplying each of the terms in the first bracket by each of the terms in the second bracket before combining like terms by way of adding or subtracting. For instance, we can expand the expression a plus b times a minus b by multiplying a by a minus b and multiplying b by a minus b. A times a is a square, and a times negative b is negative ab. So the first bit of the expression expands into a square minus ab. B times a is ab, and b times negative b is negative b square. So the second bit of the expression expands into ab minus b square. Negative ab gets rid of ab. So the expression now becomes a square minus b square. Any expression of the form a square minus b square is known as the difference of two squares. The factorized form of a square minus b square is a plus b times a minus b. Therefore, both expressions are difference of two squares. The easiest way of expanding the factorized form of the difference of two squares is to 1. Square the first term. 2. Square the second term. And 3. Express the difference between the square of the first and second terms. So back to our original expression, a plus b times a minus b. The first step is to square the first term. So we have a squared. The second step is to square the second term. That is b squared. And the third step is to express the difference between a squared and b squared. So this expression is the same as this expression. Now let's take a look at the following examples. Expand the following expressions. Solution. Example 1 says we should expand the expression 3x minus 2y times 3x plus 2y. Step 1 is to square the first term. So we have 3x all squared. Step 2 is to square the second term. So we have 2y all squared. Step 3 is to express their difference. 3x all squared is 9x squared, and 2y all squared is 4y squared. Example 2. 2x plus y times 2x minus y. We first square 2x and subtract the square of y. 2x all squared is 4x squared minus y squared. Well done! We have come to the end of today's lesson and the lessons on expansion of algebraic expressions. In our next lesson, we will look at the factorization of algebraic expressions. If you find our educational videos helpful, kindly join the virtual tutor series family by subscribing to our YouTube channel in order to receive notification on future videos. Thank you for watching and see you in our next video lessons.